Hello YouTube. This is my replication of the Tan C. Heinz regenerative acceleration generator experiment. With this experiment I'm getting the same results, and in this experiment you will be able to see that it is possible to speed up a generator under load. So let me walk you through the system. Here's my incoming grid, which goes to my watt meter over here, and from my watt meter it goes to my frequency drive controller. My frequency drive controller is connected to my normal induction motor, which is rated at 1500 RPM at 50 Hz. And with this frequency drive controller I am able to let it run at 3000 RPM, so at 50 Hz it will give me 1500 RPM, and at 100 Hz it will give me 3000 RPM, which is important for this type of experiment. Further we have, here I have my rotor, my generator rotor, with 12 magnets, neodymium magnets connected to it. North-south facing outwards. And here you see my high impedance generator coil. And my very high impedance generator coil, which is also important. Here are the specs. 2.182 Henries and 384 ohms. So to my generator coil I have connected those two wires which go to my multimeter, which show the hertzes which are coming out of the generator, and in parallel I'm able to connect this light bulb, which is an LED light bulb, so I can connect it, and which is rated at 1 to 2 watts. So for now that is the system as a whole. Let me place my camera over here so that I can start it up. Yeah, everything is on it. All the wires are on it. Okay. For now, what I will do is first I will start my motor to 50 Hz. There we go. And when it's up to speed, you can see that now my generator is almost generating 150 Hz, almost, so 148.8 Hz. And when I try to load my generator for now, the wattage will increase. So now it takes almost 58 watts, 57.9, and when I remove my load, you can see that the system drops back and goes to 46.4 watts. This is the wattage which is needed to supply my frequency drive controller and to let my system run idle. So one more time. 57.6 watts with load connected. 46.2 watts with the load disconnected, so when it's running idle. So this is normal generator action, and now comes the magic. One moment. What I now will do is I will crank up my motor speed to 100 Hz. So now this motor almost runs at 3000 RPM, which gives me almost 300 Hz out of my generator coil. I have to hold this because it tries to move away. And now comes the interesting part. At idle you can see that it needs 76.3 watts, and when I connect the load to it, you can see that it drops to 73.8 watts, 74, and when I remove the load it climbs back to 75.8 watts. So with the load connected, it will take you less energy to supply this light bulb. This is the interesting aspect. So Tan C. Heinz is right, and this is a very important aspect. So let me stop the motor for now. There are only two parameters which are very important. That's the high frequency to the generator coil. So in this case you will get it to connect more magnets on the same rotor. That will speed up your, that will crank up your frequency, and the very high impedance coil. Oh, one more thing what's also important to mention is, let me speed it up again. It goes to 100 Hertz. So now it's back up to speed. When we connect the load, we see the same effect. 75 watts, 74.7, 0.6, 0.5 and 4. When we disconnect it, you see that it increases. Load connected, the power will drop, and load disconnected, the power will increase. What I also want to show is when I try to introduce drag by hand, then you see that, that there is more power needed. So for now you see when I put my finger on it that it almost needs, it's coming to get hot, it almost needs 140 watts. So those are real watts, that's important to mention. And the second value is volt amperes, the first value at the top is watts, and the third value is the cosinus V. So one more time, when drag is introduced it will take you more wattage, and now let it drop back to idle. Now it takes 74.3 watts, connect the load again, and you will see that it slightly increases to 72 watts, 74 back, disconnected, load connected, 72 watts, and you can also see that the frequency is a little bit higher, 0.9, and when the load is disconnected it is 0.7. So it's very interesting. Let me stop it for now. And the only thing what I also wanted to show you is this. This is the schematic, so that you have all the parameters. Normal induction motor, frequency drive controller, rotor with 12 magnets on it, high impedance coil, and the load connected to it. This is my setup. Okay, that was it. Thanks for watching.